Welcome to our office. This is where basically LUSH are based down in Poole. We've got a number of places around here. This is kind of our technical home. We've got guys up in London. Feel free to sort of have a look around this area, around in here. Back in December, I did a talk kind of just about how we in LUSH do our sort of pipelines, our builds, deployments. I know personally, I find it really interesting when other people talk about how they do things, what they're doing wrong, all this sort of stuff. So I did something very similar. This is now a few months on, and basically what I didn't want to talk about tonight is just a few little points, things that maybe seemed like a really good idea at the time, but now we're thinking maybe we shouldn't have done that. And it's kind of, there's no criticism in what we're doing, but some of the stuff that I talked about in December, the guys that were there will appreciate it was pretty cool stuff we're doing. We're moving very quickly. Our estate, we're using GCP for a lot of stuff. We're on Kubernetes, running vast majority of our backend in Golang, bits of PHP, things like that. We've got React front ends. It's all we're using modern stack, and we're moving very quickly, and we're pushing forward. So in here is a few little things that maybe didn't quite go so well, and you might want to keep an eye out yourself if you're thinking of doing something similar. So since December, we've now also rolled out our till system. Well, I think it was out there before December. I keep looking at Ben because he's nodding away at the back. Basically, we had a till system. I think when I spoke last time, we were kind of just rolling it out, and it was relatively new. That survived the whole of Christmas. We had no issues. That's every store sort of UK-wide. That's our own native Android application written in-house with our own till system. We've also got native Android and iOS apps. We've got if anyone looks I know on iPhone, you can get the LUSH Labs app, which is it was written for our Japanese store, and it's basically built on machine learning algorithms where you can basically visually just look at images, products, and it will tell you what it is, and things like that. We've got a store in Japan where we don't have any label, we don't have any packaging. The idea is that there's just nothing, there's no wastage. So you just walk around, take a picture, and it will show you what it is, all the ingredients and all that sort of stuff. So we're working on that, we're rolling that out and other things like that. Right, I need to crack on. Because I will either overrun or be really short. This was a slide I used in December. It was a quick recap on what we're doing and how we're doing it. I'm focusing on the back-end applications. So basically our API gateway. This is new since December. We are now working with Cockroach considerably more than we were before. So those who don't know, Cockroach DB is a Postgres compliant database. If you've ever used things like Elasticsearch and built clusters and added nodes and it scales out really easily, Cockroach does that for databases. The idea going forward is that this will be our data layer globally, so that we don't have to worry about replicating data around the world. We're using their hosted system service, so they maintain that for us. They give us endpoints, pretty much anywhere on the globe. We talk to that, we will get the local instances. Built into it is things like data sovereignty configuration, so you can say this data cannot leave this country, and it will stay on the disks in those relevant countries and so on and so forth. Because going forward, we want to roll out globally. As I said, currently our till systems in the UK. Very nearly on the horizon is Japan. We're going to have a store over there. We've got one in Berlin on the new till. And we were at South by Southwest Festival not very long ago. We ran a till out there as well. So that was, as I said, that's what we did before. We've got loads of services. The architecture, I can't remember what I said before and what I didn't. The architecture is basically service database. We try not to share databases behind the scenes because, as you probably know, that leads to all sorts of confusion and mayhem when you're trying to split them up and move stuff around. So that's kind of a high-level architecture. So back in December, one of the things we do is I showed this slide. I showed it piecemeal, so if I throw it at you, it looks a bit more confusing. But the idea here is basically the devs push to a service. If it's on the master or a branch, then it gets built, it gets deployed to staging, and it gets deployed internally. So the master branch is available at the service endpoint. Any other branches get deployed as well in stage, so the dev can see all of the branch code deployed running. If they then tag master, it gets built, it gets deployed to staging, it then goes to prod. So what we basically said here is the major version from the tag is basically deployed publicly. So I say publicly, it goes through an API gateway, but so our front-end services can access different versions of the back end. So if new functionality is required, it's a breaking change, we can roll out, we can increment, major version, that gets deployed alongside and they're all publicly accessible. So anything using the old one continues to use the old one. One of the issues we've kind of going forward is this is the way we're doing it at the moment. Of course, you tag on master, that gets built into a Docker container. I did say my diagrams are really basic. This is it. I've got color on this one. I didn't have that in December. So we basically deployed V1. That gets deployed in our Kubernetes cluster. That's accessible at the V1 endpoint. Then time goes on, breaking changes get made, V2 gets cut, that gets deployed as well. What I didn't mention here actually is that the latest version always gets deployed to an unversioned namespace as well. So if you access this, you're just hitting the bleeding edge, well, say bleeding edge, but tested, tagged, newest version of the code. So that's kind of just symbolized by these dashes here. There's probably quite an obvious issue you may see with this, one of which is we're up here, we've moved on in time, we want to update or patch dependencies, that sort of thing, it's back here. So it's really hard to get back to patch an older version. You can do it, you can branch code, you can mess around, you can do all sorts, but it's not nice. The other issue we get is people depending on the unversioned endpoint, then that changes, because we deployed V2, we replaced this, and they complain that it's broken. We're like, so going forward, we're not keen on having some version. You want our front-end guys to know, to be basically pinned to a version. So going forward, one of the options we're going to do is basically go with that. Personally, another option would be run a single binary with all the versions available to it. Benefits of that being when you rebuild V2, you're also rebuilding everything else. You're downloading all the latest dependencies, anything that may have been security patched and fixed and so on and so forth. And you're constantly rebuilding the older version of the code as well. So that's one thing that was a really nice idea at the time, but it does give us a few headaches. Another one, a decision was made a long time ago to try and keep the tagging model of Docker images as simple as possible. So we ended up basically with kind of this structure where anything on the master branch, when it gets pushed, it gets built, gets pushed to a Docker registry, and it gets tagged with latest. That then gets deployed to stage. So at any point in time, you can just grab the latest. This is just doesn't exist, but it's a fictional Docker registry. So at any point in time, you can pull the latest image, run it locally, or whatever you want. Then, of course, other branches get their branch name appended as the tag. And as soon as a version of the code gets tagged, then it's marked as stable, then that gets deployed. It's a nice idea, and it's simple. Yeah, it's a nice idea. But the issue you're going to get, for those that don't know, I know there's a lot of stuff on here. This is a Git Lab Ci Pipeline file. So this basically just tells GitLab. It's a YAML file that lives in the code repo. So if you ever push to a registry, it's got that. It then kicks off the Git Lab pipelines. But what we're looking at there is basically a simplified version where you have a build and a deploy. Then we have our 3 different types. We're building the master, if it's a master branch, building any branches if it's a branch but not master, and so on. Then you've got the same thing for deploy, master, branches, and prod, so anything tagged. Now you notice that basically we're calling the same script all the time, and then we're just passing in an argument that says this is the tag, this is what it should be called. But the issue we end up with is there's one of our projects, this is just the Docker registry from Google. Actually note that one of the nice things in GCR is they will scan your Docker images for vulnerabilities, like in the background, and let you know, which is a really nice feature. But what we end up with is Docker images, then we're tagged with kind of the latest and stable, as I said. This was the one with the tag on it. But of course, in Docker, these can move. You can move tags around. It's not stuck to a commit like a Git tag would be. So what you're ending up with is a Git Lab Ci Pipeline file that lives in the code base, which is at a point in time was committed with the code, and it basically just says, I'm going to build latest, I'm going to deploy latest. Now, Ben's face. One of the issues you may find here is that basically, so the GitLab, the build config is pinned to the code. That's quite nice. The Docker image is no longer solidly linked to the code, the commit at the time. So, for example, this would have built and pushed to Docker with the latest tag, so would this, so would this. Now, people who don't know GitLab, these are basically the stages listed in that CI file. So one of these will be deploy. So you've done some builds. For example, if these were some other branch that Ben was working on, if you wanted to redeploy an older one, he'd rerun on this stage, but it's going to redeploy the image with the tag matching his branch or latest, not necessarily the code that was actually built at this point in time. So you've kind of got this disconnect between your artifacts and your code base. And that's a hell of an oversight. At the time, it seemed like quite a nice way of doing it, but then in looking at it now, don't come back to that. So that's one of the little things that we're slowly changing. One of the options is we actually scrap all this and use the git commit as the Docker tag. So no longer, you can also stick on like a latest or a branch name or the major tag if you really wanted to, but from a deployment and build point of view, we're using the git hash to reference the deployed artifact. You'll notice I've actually had to prepend it? Yeah, with git hyphen. That's because if you're using Kubernetes with Helm, if it's only got numbers, it sees it switches it to scientific notation, and it just causes a ball ache. So I've forced some characters in there to keep it as a string. But then it also simplifies our GitLab build file because we only build it once, and then the deploys are just referencing the code commit. Config and repos. 12 minutes. It's an interesting one. There are two distinct camps. Do you put your configuration for your applications in your code base with the application code, or do you keep them separate? We are a big fan of keeping it kind of with the application. One of the reasons for that is, let's put my notes up, it keeps everything together. So we've got lots and lots of microservices, like loads and loads of repos. We don't really want to have all our configuration somewhere else. Trying to keep those two things in sync is a nightmare. So if you can keep your configuration alongside your code, it's all there. Developers aren't kept away from the production configuration. Why should they be? I've worked in enterprises in the past. I've worked in all over the place where you have your developers who do stuff. You have your operations team. I'm looking at Jorge because he knows exactly what I'm talking about. Developers want to deploy to live, and Jez. They then have to request that the operations team make some changes to configuration and then go, why do you have dev and ops with a massive wall in the middle?
Can I ask a question then? Because when I've done this before, how do you protect the Git Lab Ci YAML file? How do you stop the developer doing something and changing the build process?
Why can't they change the build process?
You've got a build process in there. It's just something I struggle with, and I've done something in the past, is to say, how do I protect that particular file? Because that's,
yeah, there is that. But then you look at things like the whole DevOps methodology. That we are not development and operations. I'm not 100% responsible for the build and deployment. We work with the developers. We communicate together. If they want to make changes to the pipeline, that's fine. Generally, they'll just say, is it all right? Will this still work? Because there may be different teams that have more specialist information, knowledge. They may know that if you change something in the build, it's going to balls up something in GCP. But generally, there's no reason we try and work as closely together as we can. It is DevOps. It's a single team with just a bit more specialist knowledge in different areas. No one can do everything. I know if you look on any employment site, they want full stack, which includes infrastructure and DevOps, and one person can do everything. No, everyone has specialities. People like what they like. They don't like everything. So we've got no problem. The devs have access to these files as well. Of course, one thing that comes up time and time again is secrets. How do you keep secrets in a code repo? We've been playing with something called SOPs from Mozilla. But basically all SOPs is you can create a YAML file, JSON file, .env or .ini files. We use Google, so we're using GCP's KMS. I know Amazon's got their KMS. You can use PGP. The idea being that SOPs will encrypt the file using the KMS key, but it keeps the structure the same. So like a dev can open this and they will see all the keys, but the values are just completely obfuscated. They're good. And then it also sticks in some metadata in the file referencing the key that it used to encrypt it and things. So the fact that my user has the ability to use that key, so my Google IAM user, I can make use of the KMS key, means that I can view the file in plain text, I can encrypt it, and then when it gets deployed, our deployment server also has permission to just decrypt stuff. So it has access to decrypt the file. But it's really nice and it's pretty simple. I really want to show it. What have we got? Yeah, big. Can you see it at the back? All good? Yeah, cool. All we got in here is basically a config.yaml file that I made up earlier. It's got just 3 keys in it. If I wanted to commit this into my repo, of course yeah. So essentially, with SOPs, it's relatively recently since we found it. So all I'm going to do is basically encrypt. Okay, let's do that. Might have to make it smaller again. So I'm basically just using the SOPs command, GCP KMS. You can use AWS PGP, all sorts of different things here. And then just a reference to the key that I'm using. You then give it the input file. If I just run that, it's going to print it as standard out. And you can see it's basically, there's the file. It's the same structure, the user password, and then it's munged the value. And then it's got this metadata. So anyone that has permission to use the keys can literally just do SOPs decrypt. I've got a pre-encrypted one there, and they can just dump it straight back to the terminal. The other nice thing, though, is if you don't stick it to the terminal, it will open in an editor, so it's editable. Another value. Save it. Cat, what is it, SOPs? No, config, encrypted. Yeah, and it's stuck that other one in. So from an ops point of view, or because I've got access to, well, so do some of the devs, but basically because we're building the databases, I set the credentials up and then we can stick them in here really easily and then commit this. It's not a problem. As I say, anyone who's got access delegated to them can just dump that file and view what's in it. But it's nice being able to edit it in place. But if you want to know any more about that, then let me know. I've got 15 seconds. So, cluster load balancing, this is something my colleague raised. Basically, in GCP, we're using what's called who's actually using GCP? Anyone? No, everyone in AWS or Azure. GCP has something called preemptible instances. They're similar to Amazon's spot price instances. It's basically how can they offload surplus resources. So they run what's called preemptible servers. They're really cheap. They're about 80% cheaper, but they are guaranteed to live no longer than 24 hours. And they will just get killed and another one appears. You may lose them. If they suddenly start running out of resources, they may also disappear as well. The issue we've got using Kubernetes, our stage cluster is about 35 nodes. We've got a few of them that are permanently running, and the vast majority are these preemptible nodes. So if you throw your 2,500 pods that we've got at this cluster, it will be nicely organized. As these die, Kubernetes does a really good job of rescheduling, and things migrate to the static servers, basically. It's just something to watch out for. Especially long-living pods, things that don't restart very often, they're all going to end up getting scheduled on the static servers, and then you end up looking at it, and a quarter of your state's got everything, and the rest are completely empty. Kubernetes won't rebalance. It's not its job. It only does it at the point of schedule. Does it look and say, where can I fit this stuff in? There is a tool that my colleague Harry's playing with called Descheduler, and you basically run it on a cron, and it will look at the estate and try and work out where it can move stuff around. So that's something it's been biting us a bit at the moment. No, I've not got time for this, I'm afraid. This slide back in December, I basically said that when we do deploy to sort of stage and branches and stuff, we spin up infrastructure as required. So maybe a branch needs its own database. It will get a new database. We don't always need data, but like in Google, they're not cheap. Same as RDS and Amazon. In spinning up this stuff, it doesn't always get cleaned up. It gets left behind. And one that caught us out a lot is in Google, if you create a database, that name is reserved for 7 days after deletion. So if you're testing your deploy scripts, so you build some infrastructure, you delete it all, then you run it again, you can't for 7 days. Because the database name we used was generated from tags and names and all sorts. So it tries to recreate the same database, and it doesn't. It's a 7-day. It used to be 3 weeks. They brought it down to 7 days, so we're heading in the right direction. Config repos, cluster load balancing, trying to be too clever. We're looking at Terraform at the moment, so it's not that difficult. If we need a new database, they can just add a line into a Terraform file. We can then just merge it into the main line, and then it gets pushed out. Very quick summary. Sorry, Link. Yep. Basically, running multiple versions is awkward. It's a pain in the ass. Don't do it if you can help it. So that was basically a code commit to an artifact, and also the config. And what do you do with config? If you want to change at the moment for us, it doesn't take long to rebuild and redeploy because our apps are pretty damn small and tidy and cute and really nice. But if we change the config, that lives in the code base. So a push kicks off a redeploy, a rebuild, and a redeploy just to get that config change out. So we have, sometimes you just kind of think, I could just jump straight in and change the config. So yeah, pros and cons of putting the config in the code base. If anyone's got any ideas of that, then give me a shout afterwards, because I'd love to know nicer ways of doing this stuff. Basically, that bottom one is you don't want to deploy a job that can do absolutely everything. Because what we've done with applications, big, massive, monolithic applications, we've broken them up into modular components. But then our infrastructure and automation is going the other way, where we're trying to automate stuff using funky regexes and auto-generating names to build infrastructure and stuff like that. But it can bite you, as we found with databases and things like that a lot in the past. And as I said, some of our applications may need to be deployed. They don't need a new database. It's just for testing something else. We do way too much automatically. And I think that's basically it. 4 minutes over. Yeah. I will just, while I'm here, I'm going to do a shout out for the Bit Picking podcast. It's really cool. The people who ever worked at WDS, so Mark and Greg, they do a weekly podcast. They just talk about basically IT, really, isn't it? It's really cool. It's a good podcast, and they're I don't know how many episodes now, but 20 odd or something like that. It's about that, and it's growing. And they've got some really good guests. Sometimes some special guest appearances from drunk people at conferences. But no, shout out to those guys. If anyone wants to know anything else, then give me a shout at the end. Also, got some of our developers are at the back of the room as well. So if you want to know more about the Go side of it, they are the ones to speak to.